All right, now we want to start piecing everything that we've been learning together. So the first thing I would do is I would pause this video, I would go to your graphing calculator, and I would put in the following equation in y equals 0.5 times x squared plus 1 times the square root of 4 minus x, and I'd hit graph. Okay, so please pause your video now and do that. All right, once you've done that, you should see the following graph, which I'm going to try to make smaller and put into the window. So before doing any of this work, let's see what we're working with, okay? So this is what your graph should look like, and you should sketch that. Now, the one problem with this graph is the fact that it's not showing you all of the information. There actually is a completely vertical line right here that stops at an x value of 4 with a y value of 0. And you can see that in your equation in the radical part. If you were to put in 0, you see everything goes away, so you get a y value of 0. So just be careful of that little part. So having said that, now we have our graph. Now we can piece it together. So we want to look at our domain. Remember, our domain is how far does it go left to right? And we learned the other day the only part we have to worry about here, because there's no denominator, is the radical. So remember, all radicals must be even or greater than or equal to 0, I should say positive. So for our domain, we want to find out when the square root of 4 minus x is greater than or equal to 0, which happens when 4 minus x is greater than or equal to 0. Okay, subtract 4 on both sides, and I'm running out of room, so I'm going to do my work over here. Okay, and you will see that negative x is greater than or equal to negative 4 divided by negative 1, making sure you flip your sign to get that your domain is everything less than or equal to 4. Okay, so this red answer here is for our domain. Sorry, new tablet today, so I'm still learning some stuff out. But our domain is x must be less than or equal to 4. Okay. Now, vertical asymptotes and holes, we don't have a denominator here. So in this situation, there's none. Okay? Remember, again, vertical asymptotes are in holes, or when we factor the denominator, we set it equal to 0, see what we can cancel out, and so on. So step 1, we graphed it. Domain, we looked for if there's a denominator, there wasn't, and then we looked at radicals to see what we can do with those. Now we want to look at absolute maxes and absolute mins. Well, if we look at our graph, okay, we see that we have a relative max at around x equals 3, but we want to find the exact value, which is why we put it in the graphing calculator. So if we look at our calculator, okay, remember it's second calc, and in this case, we're going to look for a maximum, so option 4. We scroll over close to the point we're looking for. We hit enter. We move to the right. We hit enter, and then guess one last time. So we see that we have a relative max at 3.13, 5.03. So 3.13, 5.03 is a relative max. Okay, if we look at our graph again, we can find an absolute min, okay, an absolute minimum at the point of 4.0. Okay, and we can find one more relative min by going back to the calculator at, it looks like it's going to be 0.1, but let's not guess. Let's actually find it out. So second calc, we're going down to option 3 for min. Okay, we're going to move to the left of it. Move to the right of it. Make sure we don't stay on guess. And we see, if I had guessed, I would have been wrong. So we have a relative min at 0.06, 0.99. So again, relative min. At 0.06, 0.99. And I really do apologize for how messy this is, but my tablet yesterday got set on fire, so we're learning about a new one. Okay. So then it says local max min values that are not absolute. I guess we covered both of those in one section.